Okay, so in this presentation, we're going to use GeoGebra to construct a perpendicular bisector for a line segment. So take notes, pause the video if you need to. After we've done the perpendicular bisector for a line segment, we will then use the perpendicular bisectors in triangles. So here's our segment AB. The technique we're going to use is with the circle tool here. So circle with center through a point. And this is similar to using a compass. If we were in a traditional geometry classroom where we were using the rulers and the compass and the protractors and all of those hand tools, this would be equivalent of using a compass, where we put the steel point on A and then the pencil point would be on B, and it would make a circular curve. Well, we're just going to draw a circle through here. So you can imagine that a compass drew this curved edge for the circle instead of our digital geometry software. And it's accomplishing the same thing. Now notice that the first circle I drew with the center at A, and then I got the radius at B. And then the second circle, I clicked B first, so the center was at B, and I got the radius distance to A. What happens here, I'm clicking my arrow tool so I can reposition everything. What happens here is where the circles overlap, those intersection points are of interest to us. So we're going to go to the point toolbar, choose intersect, and put a point at those intersections. Now I'm going to take my arrow, I'm just going to reposition my point labels. So we can see all the points and read them clearly. I'm going to draw a segment from C to D. So we come to the line toolbar, we choose segment, and I'll click on C, and then I'll click on D. Now, one more time, the intersect button, and put a point there. We could now say that this is a perpendicular bisector, but to show you that it is a perpendicular bisector, that means that the distance from A to E should be the same as the distance from B to E. So let's measure them. So here's our measuring toolbar. We want to measure distance. I'll click A and then E, and it told me that AE is a distance of 3. And then I'll click B and then E, and it told me that BE is a distance of 3. So we know that this is a midpoint because it cut the segment into two equal-sized smaller segments, each with a measure of 3. Now we want to make sure it's perpendicular, so we go back to our measuring toolbar, choose angle. We have to click the points of the angle in a specific order. So we start with the right point, we go to the vertex and then to the top point. And that's because we're measuring in a counterclockwise rotation. That is where positive angle measure is done. If I clicked it from C to E and then B, it would give me the counterclockwise starting at side C all the way around. It would not be the 90-degree angle, it would be the 270-degree angle. So the order we click it in is important. You can also choose it by the sides. If I click the first side, then the second side, we see that I got 270. I can simply come here and hit the undo button. And again, I'm going to click it by the sides in the reverse order. I got the 90 I was looking for. Or I can click undo, and I can follow it by the point order instead of the sides. And I got 90. So there's a few different ways we can measure the angles in GeoGebra. If you don't get the position of the angle you want, click the undo button, and then you choose a different way of selecting the sides of the angle or the 3 points of the angle. So we got our 90 degrees, we got our equidistant segments. So that means that E is the midpoint and that these lines are perpendicular. Therefore, this segment that we drew, CE, is a perpendicular bisector of AB.